Perhaps the oldest card force in history is the 10 to 20 force. So how this works is you ask the spectator for a random number between, let's say, 10 and 20. And perhaps they'll say 15. So you go ahead and deal out 15 cards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Very good. Well, perhaps to get an even more random location for a card, why don't we go ahead and add the digits of the number you just named, say 15. 1 and 5, that would be 6. So 1, 2, 3, 4, 5, 6. Okay, so this will be our random selection decided by the number that you chose randomly between 10 and 20. And then we simply just added the digits to further randomize that choice. So where did that bring us? Nowhere. Absolutely nowhere. Let's look at this deck here. Are these all blank? Not at all. Just that one card. Okay, so as mentioned, this is probably the most ancient of all card forces, and it is a simple mathematical force. So how this works is depending on where you want the card to be. So let me just show you something here for a write-up. If you're wanting to land on the card of interest, okay, so you actually, when you finish this, the last card counted out, you want it to be the card that the spectator will use. Then, if that's the case, then you'll need to put that special card in the 10th position from the top of the deck. If you want the spectator card or the special card to be the next one after the counting, then you'll need to put it in the 9th position from the top, okay? And we'll talk about why in just a second. So let's go ahead and just kind of illustrate that. So the first one is what I did actually. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 cards there. I'll put this in the 10th position from the top. 10th position. Okay, so we ask for a random number between, whole number between 10 and 20. So maybe they say 17 this time. So if we do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17. Okay, and then we say, well, to even randomize this further, let's go ahead and just add those digits for that number that you just chose, 17. So that would be a 1 and a 7. Those added would be 8. So 1, 2, 3, 4, 5, 6, 7, 8. There we are again with our blank card, the only one in the deck. Okay? So to get a feel for this, probably the best thing to do, we'll step through the proof in just a second, is to work with a card face up. Now, it doesn't have to be a silly blank card like this one. So it could just be any card face up. So if you wanted to start with it in the 10th position, you can just go ahead and put a face up card in the 10th position. And then if you kind of play with the different values between 10 and 20, but please note it's strictly between 10 and, well, it can be exactly 10, that's fine. The procedure works just fine, but it can't be as large as 20. So that's why we say between 10 and 20. So people will normally choose one that's strictly in between. But you can begin to see what's going on here by just playing with it, exploring. So for example, if you choose 12, so just watch what happens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? And then we request just one more randomization element. We have the spectator add the digits of the number that they freely chose, which was 12. Well, the digits for 12 are 1 and 2, add those, and it's 3. So from here, we would go count backwards now. This is the top now. So we go 1, 2, 3, and we would land on their card. Okay? Now, let's contrast that with wanting the special card to be one beyond where we land. So if that's the case, then we need to actually have that card in the 9th position. And you'll see why in a second. 4, 5, 6, 7, 8, 9. There we go. Okay, so we want it in the 9th position, and let's just check to make sure that's what I've done. 3, 6, 9. There you go. It's in the 9th position. So now they're free to choose any whole number between 10 and 20. So maybe they choose 19 this time. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Very good. And then to randomize it, the whole process further, we have them add those digits. The 1 and the 9 would be 10. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so this time, the card of interest is one beyond where we stopped. Okay, so you can kind of see the difference there. So it really just depends on where you want it to be. So this is very much a kind of a utility move, or what we just call a card force, if you're wanting the spectator to choose a particular card for some reason. So let's just quickly, the proof for this is incredibly elementary. So, so most of you maybe won't even need to see this part of it. Okay, now every whole number between 10 and 20, but not equal to 20, can be written in the following form. It can be written as 10 plus some additional single digit between 0 and 9, right? So subtracting the sum of the digits of this number n from n yields the following. So we have n minus, and then the digits for n will be the 1 for the tens place, and then the ones place will be determined by this d here, digit. So if we perform this subtraction and write out what n is 10 plus d, you see immediately that the d's cancel out because we have a subtraction of everything in here from what's on the left, and then we still have a subtract 1 from 10. So that would give us 9. Okay, so that would tell us kind of where the card would need to be so that when we finish this process of dealing out a number between 10 and 20 and then moving backwards by the sum of the digits of that number, the position 9 will enable us, as we have just seen here, to determine the position of where that card needs to be so that at the end of this process, our card of interest is one beyond where we have counted. And of course, what the proof shows here is this answer of 9 is independent of the value of d. d can be any digit between 0 and 9. So anyway, that's the 10 to 20 force. It's once again, I'm not even sure how long it's been around, but I suspect it's been around a very long time. But for those who are not familiar with card magic, and especially mathematical card magic, they may not be familiar with this. And it certainly gives the appearance of kind of randomization because they were free to choose any number between 10 and 20, and you would think, and many spectators do think, that, well, you know, if I add those digits and then subtract from this randomly chosen number, surely that's still random, or even more random now, you know, kind of thing. Well, what happens is when you subtract the sum of the digits, it ends up giving you the same answer independent of the number that you chose between 10 and 20. Thanks for watching, and I thought I would share that one since it is a classic mathematical artifact.